Hello everyone. In this short video, I will do an example of determining interval of increasing decreasing for a function using its graph. The example goes as use the graph of the function f of x is equal to 1 over x to determine the intervals on which f is increasing or decreasing. Well, something that you may know is the graph of this function. It's a simple rational function, and what it does is it goes like this and it goes like that. And okay, so we have to try to see where this function is increasing, decreasing. Something that you have to right away notice is that, well, this function has two branches, yes, one here, one there. And on this one, as we move to right, it goes down. And on this one, as we move to right, it also goes down. So at least we can say that f is decreasing on both intervals, negative infinity to 0 and 0 to plus infinity. Again, remember that when we are doing the increasing, decreasing, we always deal with open intervals. So in this case, also this is open interval. Some may think that, well, it seems that we have the whole real line. Why don't we write f is decreasing on real number, on the whole thing? But you have to be very careful. That 0 is a point on which the function is not defined. So the function is not defined at 0. I cannot plug in 0 there. Yes. And what happens? That changes the whole story, because you see, for a value like f at -1 and f at 1 and f at 1, you see that, well, x1 is less than x2, but I cannot say that f of x2, which is 1 over 1, is less than f of x1, which is -1. It is actually the other way around. And what is important here is that the 0 is this continuity point for this function. And at that point, suddenly the graph of function changes. It just produces completely new branch. So the function, yes, it is decreasing on negative infinity to 0. It is decreasing on 0 to infinity, but it is not decreasing on whole r. Actually, it's not defined even on the whole r. It's not defined at 0. So this statement, it may seem correct, but it's not correct. This is the correct statement.